All right, for our February 4th notes, we're going to start reviewing radicals, which is that square root symbol. We do call them radicals. We're going to talk about simplifying and dividing for today. The first thing we'll talk about real quick is just your different parts of the radical. We're not going to be dealing with this little box here, but a lot of times in geometry we will not, but when you see a number right there, this is what we call the index. Again, we're not going to have to focus too much with that. The actual sign is just our radical sign. Okay, that tells us to take the square root. The number on the inside, that's where this box is, that number is what we call the radicand. Nice vocabulary words for you. These next 25 numbers are your first 25 perfect squares. It is very, very highly suggested that you memorize as many of these as possible, because this is only going to make your life so much easier in the next unit to come. Making sure that, here we got all these numbers, we square them, we're going to get it over here. 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. As many as you can get memorized, the better. The more you can, the better it's going to be. So let's talk about simplifying these. You're going to simplify when we can actually pull some whole numbers out. There are a few different ways that you can do these simplifying your radicals, and I've listed two of them here. You've got your factoring, which is just using your prime numbers. So up top, above this, let's go ahead and write out some of our prime numbers. We've got 2, 3, 5, 7, 11, 13, 17, and so on. Remember, prime means it can only be divided by 1 in itself. When we're dealing with the prime numbers, you're usually not going to go much farther than 11 or 13. So we're going to factor this square root of 63. Let's take a look at what this happened with our factoring. This is going to be a factor tree, okay? With your factor tree, if you have the square root of 3, we want to look at prime numbers. Take a look at our first prime number, 2. Can 2 go into 63? No. Let's move to the next prime number, 3. 63 can be divided by 3, and it's 3 times 21. So we leave that 3 alone now, and let's move down to our 21, and let's break this guy down. We cannot divide by 2, so move to the next prime number. We can divide by 3, and that's 3 times 7. I am left with nothing but prime numbers now. At the end of each one, the 3, and the 7. What happens with this radical sign? Okay, I call it in the house and out of the house. The numbers that go out of the house are numbers that have a partner. Outside of the house, they're having a three-legged race. So in order to have a three-legged race, you have to have 2 people. So in order to have the three-legged race, the numbers have to have a partner to go outside. Now when you're in a three-legged race and you cross the finish line first, you don't get first and second place. You both get the same place value. So that means these 3s are one number. So we're going to write 1 3 outside of the house. And then the guy that's sitting all by himself that does not have a partner, he cannot be in the three-legged race. So he has to sit inside by himself. Okay? And there you go. And we'll talk about what happens if you have more than one inside or outside in just a minute. Now, I want to show you a way you could do this with what I call the division tower. This is another way you can use it's still factoring, okay? But I used to really, really like this. Once we get into geometric mean, the factor tree is probably going to be one of the easiest. Division tower will start at the bottom. So we have the square root of 72. You're going to divide by your prime numbers. Again, starting with the first. 2. Can we divide 72 by 2? Yes. It's an even number. 72 divided by 2 is 36. So exactly how we've always learned to long divide. We're going to build on top of that. Now we're going to divide 36 by the smallest prime number. We can divide by 2 again. We divide 36 by 2, we get 18. Keep building that tower until you're left with a prime number. Divide again, we can divide by 2, we're going to get 9. We divide again, we can no longer divide by 2, so let's move up to the next one. 3, can we divide 9 by 3? Yes, we can. And it's going to leave us with 3. Now that we have a prime number at the top of the tower, we're done. Now we're going to go find our partners, okay? So here's our radical house. And what we're going to notice is here's a partner, so they're going to go sit outside and wait. And then this 2 right here does not have a partner, so he's going to go inside by himself. You cannot put 3 of them together. Okay, we do not have another 2 for him. And then I also see a pair of 3s, so they're going to go outside as well. And what happens is, everybody outside you multiply, everybody inside you multiply. So here you would take 3 times 2, and you get 6, and you just leave that square root of 2. What's really, really great about this, I'm going to pause real quick so I can grab my... What's nice is you can check to see, did I do this correctly? If you look on your calculator here, you take your original square root of 72. So on here you press Control X squared, type in that 72 and get your answer. Then take your simplified one, 6 square root of 2. You just type in the 6, then the square root sign, then 2, press Enter. If you simplify correctly, look at that. I suggest you do that with your answers so you can double check to see, did I simplify them correctly? All right, going on to the next one here. Let's take a look at 2 the square root of 8. Now, when you already have a number outside that radical house, let's take this radical house that we're going to end with. When you have a number already outside, that means there's already a pair waiting to do the two-legged race. So what you're going to do is you're going to take that guy and you're going to go ahead and place him outside. He's going to wait outside. And you're just going to focus on that square root of 8. And I'll do the factor tree here again. Okay, so here, 8, we can do 2 times 4, and then 2 can be broken down to 2 times 2. So here's another pair of partners that's going to go outside with that original 2, and this guy right here has to stay inside. We multiply that 2 times 2 to get 4, square root of 2. And again, you can check in your calculator. Now, the other way that you can do these is using a perfect square. This is where you're going to want to have your perfect squares memorized. So it makes it a little tougher. You have to have those memorized. If we take the square root of 63, try to figure out what perfect square could go into 63. And we're looking at our perfect squares right here. Okay? Obviously, it can't be 64 or higher because we're looking at 63. So aim a little bit lower here. You could just divide by these perfect squares and figure out which one goes in. This one's going to be 9, which is a perfect square, and it would be 9 times 7. So then you could just break this down to 3 and 3. So again, here's your partner that goes outside the house, and here's the alone guy that goes inside the house. So let's take a look at the perfect square. The perfect square on the other one. We have the square root of 72. We're going to go through, figure out what perfect square could go into 72, and I'm going to find out that I can go 36 times 2. 36 is another perfect square. And then here we can look at 36. You can break it down as 3 times 2, just whatever 2 numbers. Okay, at this point I like to just break it down to, like, let's say 4 times 9. 4 will break down to 2 times 2. 9 will break down to 3 times 3. So here I have a partnership that'll go outside the house. Here I have a partnership that'll go outside the house. Oops, sorry, that should be a 2. And then don't forget about this guy up here at the very, very beginning. That's why I don't really like the perfect square. The factor tree can get a little iffy because you might forget these guys up here. With the tower, it's harder to forget them. But always double check with your factoring to make sure that you got this lonely guy. He's going to go inside, and there's where we get our 3 times 2. We get our 6 square root of 2. And the last one, again, with that 2 square root of 8. We're going to go down to that house. We're going to go ahead and place that 2 out front. 8, the perfect square that can go into it is 4. It would be 4 times 2. And the 4 breaks down to 2 times 2. Here's a partnership that'll join outside. And this guy all by himself stays inside, giving us our 4 square root of 2. You decide which one you like best. Okay? On the next 3 examples, I'm not doing all of them. Okay, I'll switch between the factor tree and the building a tower. Okay, so the next one here we have 6 square root of 32. You'll also hear 6 radical 32. So we're going to go ahead and hang out our house down here because we have that 6 that's already waiting outside. We're going to go and take him and place him outside the house. See if anybody else can join him. With 32, what I'm going to do is I'm going to go ahead and do the division tower. 32, looking at our prime numbers, starting with 2. Yep, we can divide by 2. We get 16. We can divide by 2 again, and we get 8. Divide by 2 again, we get 4. We're still not at a prime number up top yet. Divide by 2, we get 2. Now we have our prime numbers. Find our partners. Here's another one. Going to go outside and chill. Here's another partnership. They're going to go outside and chill. And then that one lonely 2 goes inside all by himself. So then you multiply the 2 times 2, you get 4. Times 6, you're going to get 24 square root of 2. And again, you can go into your calculator and you can double check. Okay, well, let's see. We type in that 6 square root of 2, which we have, 6. 6, do our control x squared, square root of 32. Press enter. And then get our simplified, our 24 square root of 2, and we get the same number, so we know that we simplified it correctly. You should always have a number down here that cannot be broken, it cannot be factored out like these, okay? So let's take a look at the next one now. We've got 3 square root of 125. So I'll go ahead and do the factor tree now. So we know we need that radical house, and we know that 3 is going to go sit and wait outside. So let's take the 125. I'm going to bring it over here. We break this down, and we could say, okay, well, I can multiply, let's see, 25 times 5. This 25 can now be broken down to 5 times 5. And all I have are prime numbers left, so I'm done factoring. Find my pairs, the join outside with 3, and to find my lonely little guy, 5. I put them on the inside. 5 times that 3 is going to give you 15, and then we leave that square root of 5. All right, ladies and gentlemen, last one here. Okay, here's our radical house. That 4 is going to wait outside to see if he has any buddies to join him. I'm going to go ahead and do the division tower on this one. We've got a big number here. We have 216. It is divisible by the smallest prime number of 2. And I'm going to wind up with 108. It can be divided by 2 again. And we're going to get 54, still an even number, divide by 2. And we're going to wind up with 27. We no longer can divide by 2. It's not an even number. Can we divide by 3? Yes, we can divide by 3. We divide by 3. It's going to give us 9. Divide by 3 again. We get 3. We have a prime number at the top of the tower. We're done. Let's find our partners to go outside with the 4 and do the 3-legged race. We have 2s here. Oh, that 2 doesn't have a partner. All right. Well, here are a pair of 3s. They can go outside. So now we have this lonely 2 and this lonely 3. We cannot put them together in a 3-legged race. That's like putting a 5-foot person with a 7-foot person in a 3-legged race. Hilarious to watch, but it's not going to work. So because they do not have an exact same size number to partner up with, they both have to go inside, and you multiply everything on the outside together separately. So you're 4 times 2, 8, times 3, you're going to get 24. And then you multiply, did it again, writing the wrong numbers here. And then you multiply everything on the inside together. The 2 times 3 gives you 6, and there's your final answer. With dividing, the rule with dividing is going to be that you divide outside divided by outside and inside divided by inside. You cannot divide the insides with the outsides. Okay, they have to be alike. So this first one here, what I want you guys to see, there's another way you can write this. You look at A and B, they're exactly the same. This can be rewritten as the square root of 10 divided by 5. So if you like to see it that way better, go for it, because here you can automatically see 10 divided by 5 is going to give you 2. Do not forget your radical sign, though. Very, very important to remember that radical sign. So here at B, we look at this. We have our radical sign. 21 divided by 3 is just going to give us 7. So our answer is the square root of 7. We always want to make sure that these are simplified as well. Okay, always make sure they're simplified, and these are. Both of these are prime numbers. They're all square root of prime numbers are simplified. Over here, again, if you'd like to see it better this way, where you have 40 divided by 5, we know that 40 divided by 5 is going to give us 8. And we need to check to see, okay, is 8 simplified? Let's do our factor tree. We can do 2 times 4. Oh, look at this. 2 times 2. So we needed to factor that one out. We have to simplify there. So here's our radical house. We have a partner to go right here. And then we have this little lonely guy that needs to go inside. So divided and simplified, there is our final answer. All right, next we have the square root of 150 over 2. This is going to give 150 divided by 2 gives us 75. So we need to take 75 and we decide, okay, can we factor this out? Let's see. Okay, so I know I can divide it by 5 and it'd be 5 times 5 times divided by, let's do 3. Let's do it by 3. 3 times 25 is going to give me 75. Well, 25 can still be factored out as 5 times 5. So here's my factor tree. Here are my partners that go outside as a single participant. And then my one little lonely guy doesn't have a partner, has to go inside. He doesn't get to participate. Now, with the next two, we have numbers on the outside as well. So we're going to divide the outsides with the outsides, the insides with the insides. So here we're going to have 8 divided by 2, and we're going to wind up with 4. And again, if you'd rather see this as the big old square root of 12 over 2, you can. It's going to wind up being 12 divided by 2, square root of 6. 6 is factored out. You can always double check and say, okay, let me factor 6, 2, and 3. I have prime numbers and they don't have any partners. So this is already factored. All right, so here's our final answer here. On the next one, we have 9 divided by 5. Now, 9 cannot be divided by 5. So what we're actually going to do is we're going to leave this as a fraction, 9 divided by 5. But I took that fraction bar and I made it longer for a reason. Because when we divide 15 by 3, we need to make sure that radical sign is on top, okay? Because the bigger number's on top. 15 divided by 3 is going to give me 5. Okay, and we cannot simplify the 9 over 5, so this is our final answer right here. All right, so that is simplifying and dividing your radicals.